Welcome everybody to the next video in our series on parabolas. And so today we're going to be talking about the vertex form for a parabola. So a good place to start is a review of our standard forms, or our forms for parabolas. And the first one that we have is our standard form, our y is equal to ax squared plus bx plus c. Then we've got vertex form that looks like y is equal to a times the quantity x minus h squared plus k. And then finally we have factored form that looks like y is equal to a times the quantity x minus p times the quantity x minus q. So the one that we're going to be interested in today is really the vertex form. So here we've got y is equal to a times the quantity x minus h squared plus k. So to review just a little bit kind of what our parabolas look like, if we start off with any parabola, we've got this point called the vertex. Now the vertex is the point on the parabola where the parabola changes direction. And so the axis of symmetry is going to be the vertical line that kind of runs down through the middle of these parabolas, so that if we imagine taking that parabola and folding around that line, the left side is exactly going to match up to the right-hand side. Now, the nice part about vertex form is that it does exactly what its name says. It tells us we can pretty much just read off the equation immediately what the vertex is. And the vertex is going to be given by h and k. So the x-coordinate of the vertex is going to be h, the y-coordinate of the vertex is going to be k. And the axis of symmetry, which is going to be this vertical line running through the vertex, is then going to be given by the equation x is equal to h. Now, this third parameter that we've got in our vertex form, this number a is there to influence whether the parabola is going to open up or down. So if a happens to be positive, our parabola is opening up. If a is negative, then our parabola is going to be opening down. So what happens if somebody just gives us something in standard form and we want to know what the vertex form of this thing is going to look like? Well, how we get that actually comes from the quadratic formula. And so if we start off with something that looks like y is equal to a times x squared plus bx plus c, then what the quadratic formula gives us is the zeros, or the x-intercepts, or sometimes those are called the roots of the parabola. So that's going to be where this parabola crosses the x-axis. It's going to cross it in one place or two places generally. And what the quadratic formula is, just to remind us again a little bit, is that we've got the discriminant, d is equal to b squared minus 4ac, and then the equations for the roots are going to be given by x is equal to negative b plus the square root of d over 2a, and x is equal to negative b minus the square root of d over 2a. Now, kind of the important thing that we might notice about this parabola is that because it's got that axis of symmetry to it, the zeros are going to be symmetric on either side of the vertex. And so we can kind of ask ourselves, well, in the quadratic formula, when we get the values for the x-intercepts, do we see a certain amount of symmetry in that formula? Well, if we kind of write our formula for the roots in a slightly different way, we've got this x is equal to negative b over 2a plus this quantity, square root of d over 2a. And then if we've got our other root, negative b over 2a minus that same quantity, square root of d over 2a, then the symmetry that shows up is that we're taking this value and we're adding it on to negative b over 2a, and we're taking that same value and we're subtracting it from negative b over 2a. Now, what that does, if we wanted, say for instance, numbers that are going to be symmetric around 5, for example, then we can add the same number and subtract the same number at 5, and we end up with numbers that are going to be symmetric on either side of 5. So let's say that if I wanted numbers that are 3 steps to the right and 3 steps to the left of 5, I would simply go 5 plus 3 to give me 8, 5 minus 3 to give me 2, and if I look at those on the number line, those three are each going to be 3 steps to the right, 3 steps to the left of 5. Well, we see this exact thing again in the quadratic formula, but here we've kind of written it out again, being a little more explicit, and we kind of break things up. If we start off with our first root, negative b plus the square root of d over 2a, we kind of divide each one of those terms by 2a, and we get negative b divided by 2a plus this quantity square root of d over 2a. And in the second one, we get negative b over 2a minus that same quantity square root of d over 2a. Again, just like our example that we saw with 5 just a second ago, we're taking some value and we're adding it on and we're subtracting it on, and we get numbers that are going to be symmetric on either side of negative b over 2a. And so what that tells us is that the axis of symmetry is given by negative b over 2a. Now for the vertex, our vertex, remember, is going to be h and k. Well, our k value is really just, k is going to be the y value of the vertex. Well, we already know that the x value for our vertex is going to be negative b over 2a, because that's the x value where the axis of symmetry is running through. So we know our x value is negative b over 2a. We can get our y value by just plugging back in to the original equation. So if we've got x is equal to negative b over 2a, we can plug that value in to find y. And so let's take one for example. Suppose that we're given y is equal to 3x squared plus 24x plus 53. Well, first thing that we do, always when we've got our standard form, what are our values for a, b, and c? Well, we've got a being 3, b being 24, and c being 53. Well, our x-coordinate of the vertex, negative b over 2a, is going to give us a negative 24 over 2 times 3. That's a negative 24 over 6, which is just negative 4. Now, that x value for negative 4, we take it and plug it in to our equation, y is equal to 3x squared plus 24x plus 53. If we plug that value in, and then we've got 3 times negative 4 squared plus 24 times negative 4 plus 53 gives us a value of 5. And so our vertex is going to be negative 4 and 5. Now let's kind of take an example that we have in standard form, go through everything that we kind of know now, and rewrite this and put it in vertex form. So we're taking our equation, y is equal to negative 2x squared minus 16x minus 35. We're identifying a, b, and c. So we've got a being negative 2, b being negative 16, and c being negative 35. Well, since a is negative 2, that's obviously less than 0. Well, that's telling us that, yes, our parabola is opening down. Our axis of symmetry then is going to be x is equal to negative b over 2a. Well, that's going to be a negative of negative 16 divided by 2 times negative 2. That's going to give us 16 over negative 4, or a value of negative 4. So our axis of symmetry, x is equal to negative 4. Well, that's also the x value for the vertex. And so if we take x is negative 4, we plug it into our original equation, our negative 2x squared minus 16x minus 35. We plug that in, and we're going to get a value of negative 2 times negative 4 squared minus 16 times negative 4 minus 35. Well, we evaluate that, and we see that we get a y value of negative 3. And so our vertex is going to be at negative 4, negative 3. This is all we really need for the vertex form. We know what a is, we know what h is, we know what k is, and so our vertex form looks like y is equal to negative 2 times the quantity x plus 4 quantity squared minus 3. So why did it switch? Well, in our vertex form, it's supposed to be x minus h. So we would really have x minus a negative 4, but x minus a negative 4 is x plus 4. And so that's why our vertex form, y is equal to negative 2 times x plus 4 quantity squared minus 3. Okay. Okay, let's do the same thing with another example. Suppose that we have y is equal to 2x squared minus 12x plus 13. A is going to be negative 2, B is going to be negative 12, and C is going to be 13. Well, again, A is going to be 2. Since 2 is positive, we know our parabola is opening up. Our axis of symmetry is going to be x is equal to negative b over 2a. So that's going to give us a negative of a negative 12 over 2 times 2. So that's 12 over 4, which just gives us 3. So our axis of symmetry is x is equal to 3. And the x-coordinate of our vertex is also x is equal to 3. And so if we take that 3, plug it into our original equation, our 2x squared minus 12x plus 13, we get 2 times 3 squared minus 12 times 3 plus 13 gives us a y value of negative 5. And so our vertex is going to be 3, negative 5. Our vertex form then is going to be y is equal to 2 times the quantity x minus 3, so x minus h, x minus 3 squared minus 5. So now, just to kind of complete the circle with everything, suppose that somebody gives us a vertex form and we want to go back to standard form. Well, how do we do that? We do that with just simply polynomial multiplication. We just expand out the polynomial that we have. And so if we go back to the two examples that we just did, we started with y is equal to negative 2x squared minus 16x minus 35. We got the vertex form, which was y is equal to negative 2 times x plus 4 quantity squared minus 3. And so if we go back to standard form, that's really just multiplying out what we have. So we've got our negative 2 times x plus 4 quantity squared. Well, that x plus 4 quantity squared is just x plus 4 times x plus 4. Now we are foiling everything out, so we've got first terms x times x to give us x squared. Inner terms 4 times x to give us 4x. Outer terms 4 times x to give us another 4x, and then 4 times 4 to give us 16. So we've got all possible combinations of something from the first set of parentheses times something from the second set of parentheses. Well, our 4x and 4x we can combine to 8x, and so we got negative 2 times the quantity x squared plus 8x plus 16, and then minus 3 on the end. Well, if I distribute my negative 2, that's going to be a negative 2 times x squared, a negative 2 times 8x, and a negative 2 times 16. Well, that's going to give me a negative 2x squared, and minus 16x, minus 32, and then minus our 3 on the end. Well, now we can combine the minus 32 and the minus 3 to give us a final answer of negative 2x squared minus 16x minus 35, which is exactly the standard form that we started with at the beginning. And so now we're able to go from standard form to vertex form, back to standard form, and so we've just kind of completed this circle of going from one form to another. If we do that same thing again with our second example to kind of check to make sure that we got the right answer, we've got y is equal to 2x squared minus 12x plus 13. That's what we started with. We said that our vertex form was going to be y is equal to 2 times the quantity x minus 3 squared minus 5. Well, the x minus 3 squared is going to be x minus 3 times x minus 3. We multiply that out first, and so foiling everything out, we've got x times x to give us x squared, minus 3 times x to give us a minus 3x, a minus 3 times x to give us another minus 3x, and then a minus 3 times a minus 3 to give us a positive 9. If we distribute our 2, that's going to give us a 2 times x squared, a 2 times a minus 6x, and a 2 times 9. Well, that's going to give us 2x squared minus 12x plus 18 minus the 5 on the end. Well, we're almost there. We can combine the 18 and the minus 5 to give us 2x squared minus 12x plus 13, thereby completing the circle, and we're getting right back to where we started, so that yes, we know our answer was correct. So hopefully this has given you a little bit of insight into what the vertex form for a parabola can do for you, how to go from standard form to vertex form, how to go from vertex form back to standard form. Should give you a few examples to work with for all of your upcoming problems. So hope you enjoyed it, and I will see you all next time.